Did you know we have two separate ways of measuring how fast the universe is expanding, and both of them give completely different answers, but neither one of them is really wrong? And it's called the Hubble tension. In 2011, an astrophysicist named Adam Rees won the Nobel Prize for discovering that the universe's expansion is speeding up and not slowing down like everybody thought. He was 41 at the time, but spent the next decade measuring the universe's expansion rate with more precision than anyone before, using exploding stars that burn as bright as a billion suns for measurement. At first, it went great. His numbers kept lining up with predictions. Then in 2013, a different team released updated data based on the leftover light from the Big Bang itself, essentially a baby picture of the universe. Their prediction for today's expansion rate came out meaningfully different than what Adam was measuring at the time. Adam assumed he made a mistake, so he checked the numbers, went over it over and over again, and even brought in another scientist to check if there was an error in his calculations, and nobody could find one. Other independent teams ran the exact same experiment with completely different telescopes and still got the same result. Here's how strange the gap actually is. Imagine predicting someone's exact adult height with a single picture taken the day they were born, and your predictions say they'll be around 6 foot 1. But when you come back years later and measure that same person as an adult, they're closer to 7 feet tall. That's roughly the size of the mismatch that scientists are dealing with. Except it's not a person anymore, but it's the entire universe, and it makes things a lot more complicated to close that gap. For over a decade, nobody has explained the gap, and it's not a rounding error either. The discrepancy has stayed consistent for so long and across so many individual experiments that scientists now claim and call it a confirmed problem that they have to deal with, which means either the early universe measurements are wrong, or the present day ones are wrong, or maybe the model itself, the one that we've been using to predict everything in the universe correctly for the past, I don't know, maybe 25 years, I think, is wrong or has a real problem in it that we cannot solve yet. So as of right now, we are actually making new telescopes that are going to come in the market and try to close that gap. But that's it for me today. If you like videos like this, make sure you subscribe and like this video. And I'm going to see you guys next time in another video. Thank you very much for watching. Bye.